All right, this is lessons 4.7 and 4.8, so this is pre-algebra. Okay, and this is exponents. Okay, so here's the deal, exponents. What does that mean again? Eyes up here. I want all eyes up here. What does that mean again? Well, that's right. That's what you said. What does it mean, Jade? What's it mean? Explain. Right. X times X times X. That is X times X times X. Yes? Right?
Yes.
You with me? Okay. What does Y squared mean then? Jack, what's it mean?
Y times Y.
Are you all with me? Okay, so then, if x to the third is this, and y squared is this, then what would x to the third, y squared be? If that was one term, one thing, what would that be?
X times X times X times Y times Y.
Correct. X times X times X times Y times Y. There it is. That's what you would do. What about this? What if I have x to the third times x squared? What would that be? This is important to understand this. What would x to the third times x squared be? Yeah, because isn't this what is this guy equal to again? You've already said it. X times X times X times what? X times X, which, what is that? What is, that's X to the fifth. So whenever you have an exponent, X to the third times X squared, notice what you can do with those two things. There's three of them here and two of them here. What can you do with them? You can add them together, right? There's three of them there, times two more, it's five of them, right? Okay, not difficult. Let's look at this. What about this? What if I have 4 times 4 to the sixth? I don't expect you to write that out, but I want you to write this out for me using exponents. What would that be? What would that be? Gina? That would be 4 to the seventh, right? Because listen, even though there isn't a 1 there, isn't it invisible? Right? We just don't write the 1 there because that would be redundant, right? We don't need to write that. 4 times 4 to the sixth. There's 1 there, plus 6 more is 4 to the seventh. Agreed? Makes sense? Okay, makes sense? All right. Let's do. Well, those you have already. Okay. Well, we'll try one. Just see if you can get this. We'll go x squared times x to the fourth times y to the third. I would like you to simplify that for me. What is that? What are those guys there? What is x squared times x to the fourth simplify to? Your eyes are up here. What is x squared times x to the fourth simplify to? And then we have a times symbol here, right? So times, but we don't need to write the times symbol. And then we have y times y to the third, which is y to the fourth. Now listen, is it wrong to go y to the fourth, x to the sixth? Is that answer wrong? No. Why do we leave it like this? Just so that we can all be talking about the same thing. You put them in alphabetical order.
And it looks a bit like.
Does that make sense? Make sense? Put them in alphabetical order. It'll be a lot easier for us as a group. Okay. Using the commutative property. What about this? Okay. Looking here, please. Looking here. What is that, guy? Read that to me. 2x to the third, right? But it would be, this actually is 2 times x times x times x, right? Times 3 times x. What am I allowed to do when I have a string of multiplication? What am I allowed to do here? Move them around. That's called the commutative property of multiplication. First thing you're always going to do is, and this is important, you always are going to put the integer or the number first, right? You're going to put the number first. It's called the leading coefficient, but we won't, that's later. What is 2 times 3? Okay, they're done. And then what do I have left? 4x's. Do I go 4x? So what I do? What do I do? X to the 4th, right? If you write them like that. 6x to the 4th. Does that make sense? Okay. What if I have an uglier one like this? Negative 3x y squared times 5x to the 4th z. Ugly one here. What do I do? I'm simplifying this. What do I do, Jane? So here's the deal. We could write all that out every time. We could always write it out. What if I change this to 20 here? Do you really want to write that out?
No.
No. Okay, well, I'm going to leave it at 20 then. Just so you won't write it out. What do I do here? Always deal with what first? No. No. What do I deal with first?
Multiplication.
Of course. They're all multiplication. What do I deal with first? What am I doing? The integers, right? I'm dealing with the numbers first, right? Always deal with them first. Negative 3 times 5. What is negative 3 times 5? Negative 15. They're done. Okay? And then I have an x here, and I have 4 x's here. What does that give me?
X to the 5th.
Right, x to the 5th. Right? There's 5 of them. And they're gone. And then I have now 20 y's. Anything else to combine them with? Can I combine them with a z? No, and then a z. There we go. Does that make sense? They're gone. No. Make sense? Okay. What about this then? This is where things get a little bit crazy. Now, let's talk about this. What do we do first? In the according to order of operations, we do parentheses first, right? There's nothing to do in here, people. There's nothing to do, right? X squared, there's nothing to do. Can't do anything. So, okay, here's the deal. What is being cubed here? What is being cubed? The x squared is, right? So let's rewrite this like we did before. Wouldn't it be this? X squared times x squared times x squared. Isn't that what we're doing here? Isn't it x squared 3 times? Okay. Doing that now, isn't this x times x times x times x times x times x? Isn't that what that is?
Yeah.
Okay. So then what does this equal? X to the 6th, right? Listen, all you have to do is look at this. This is saying that this, whatever's out here, that this is going to be 3 times. 3 times, right? It's 3 sets of whatever's in here. 3 sets of x squared would make x to the 6th, right? What can I do with these two numbers here? I can multiply them, right? If it's a power of a power, you multiply them. So then let's look at a weird one. Let's go x squared y to the 3rd all to the 5th power. What this means is that there are 5 sets of what?
X and
5 sets of what? X squared y to the 3rd, right? There's 5 sets of those. So then I could write this all out. Or what can I do?
X times
I can go x squared to the 5th. So I can go this times this is 10. So x to the 10th. And then y to the 15th. Makes sense? And it should make sense. You should understand how that works because there's 5 sets of this. Well, 5 sets of x squared is x to the 10th. 5 sets of y to the 3rd is y to the 15th. Make sense? Okay. Try one. Try, let's see, what's the hardest one they give us? Oh, they're kind of easy. This is pre-algebra. Oh, one last thing. Oh, no, we won't. Well, that's not true. Okay. What is 0 to the 5th power? 0, right? It's 0 times 0 times 0 times 0 times 0. Still just 0. Okay. let's take just a really brief quiz here on this stuff. Make sure you got it. Let me look. Here we go. Let's go m to the 5th, m to the 7th. Whatever. It's just not even really a quiz. Just do it for me so I can know that you know how to do this. Just do it. Just do it. Simplify it. That's the deal. All right, here we go. Number 1. Look here. What did you guys get for this?
M to the 12.
How many of you got m to the 12th? Thank you. And here I have -5 times -3, which is a positive 15. So we just put 15, and then I have 2x's and 7x's, that is x to the 9th. How many of you got that? 15, x to the 9th. Okay, then this last one here, this is 2 sets of m to the 3rd, which is m to the 3rd times m to the 3rd, which is m to the 6th, right? You just multiply these two. How many of you got m to the 6th? Okay, good. You guys all get that. That's good. Now, dividing these things, we've done this before a little bit, so I'm going to show you something. If I have this, we've already done this a little bit, x to the 7th. Look here, I could write this divided by x to the 3rd. I could write it like that. What's another way of writing that? What's another way of writing this? Wouldn't it be x to the 7th over x to the 3rd? Isn't that still division?
Yeah.
And isn't this x times x times x times x times x times x times x over x times x times x? Isn't that the same thing?
Yeah.
And then what am I allowed to do now? We've done this. What am I allowed to do? Start going bang, bang, bang. They're done. What do I have left? 4x is on the top. So it's x to the 4th over 1, which is just x to the 4th. Now, what if I land like this? I mean, this doesn't happen. I don't think it shouldn't happen here. But what if I landed up like this? M squared divided by m to the 4th, which is m squared over m to the 4th, which is m times m over m times m times m times m. And you go bang, bang. And then what does it leave me with? M is the second. 1 over that, right? If you just put m to the second, you're wrong, people. That's not the same at all. This is 1 over m to the second, right? It's on the bottom, right? If you just put m squared, you're wrong. That's ridiculous. Okay, but that I don't think that happens to you very much here. What about this? What if I have, okay, what if I have this 10 x to the 4th y over -5 x y z. Okay, so here's the deal. Dividing these, what's the first thing I'm going to do, just like in multiplication? First thing I'm going to do? Integers, right? Deal with the actual numbers here. What is 10 over -5? It's a -2, right? So I'm going to put a negative, and the 2 is on the top, right? Okay, they're gone. I have 4 x's on the top, 1 on the bottom. When I reduce this, where is that? What am I going to have left? X to the 3rd on the top. You have to tell me where. If you just say x to the 3rd, then that makes no sense, right? And then I have y over y, which is, they're gone, right? They're just ones. And then z is on the bottom. There's our answer. -2x to the 3rd over z. Does that make sense? Okay. Try one here. Let's see. The first one they give us is okay. Here's the simple. Here's what they do: 3 to the 8th over 3 to the 5th. What's that going to give me? 1 over.
3.
Hold on. What does 3 to the 8th mean? I'm confused. What does 3 to the 8th mean? So 3 times 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 3, right? 8 of them over 3 times 3 times 3 times 3 times 3, right? Isn't that what that says? Do you really see that? Okay, so gone. What's that leave me with? 3 to the 3rd on top, right? So 3 to the 3rd. Is that one that's small enough that we can actually do? What is 3 times 3? 9 times 3? If it's small enough you can do it. That's simplified, right? If it's 3 to the 35th, no one's going to make you do that, right? What about this? X to the 4th over x squared. What's that going to leave me with? When you reduce that?
X.
What is it? I want you all to think about it. Bradley, what's that going to leave me with?
X.
What? Do this. Simplify this for me.
It'd be x to x squared over 2.
Right. This is just x squared over 1, which is just x squared, right? Because there's 4 on the top, 2 on the bottom. When you eliminate them, that leaves me with 2 of them on the top, right? Right? Okay. What about this then? Let's do an ugly one. Write down this answer. Write it down. Write down the answer for me. Simplify this. So listen, do I need to write out 25 x's on the top?
No.
Do I need to write 18 x's on the bottom? No. What do I know I'm going to do? I'm going to eliminate how many total x's am I going to eliminate here? 18, right? So when I eliminate the 18, there's nothing left on the bottom. That leaves me with how many on the top? 7. So it's x to the 7th on the top over 1, which is just x to the 7th, right? That's it. X to the 7th. What do I really need to do here? It's just subtract, right? Just subtract. It's so simple. Okay. How many of you got that right? X to the 7th? Okay. Okay. Here's the tricky one. This is the... Oh, they do go into that too. Okay. Here's something else. What if I have this... Since we're allowed to subtract, I want you to subtract again. I'm going to do it again. X to the 56th over x to the 36th. I'll give you 5 seconds to be done with this. Okay, so since we're subtracting, it's x to the 20th, right? We all got that? X to the 20th. Okay, what about this then? What if I have this? Yeah, x to the 5th over x to the 5th. What is x to the 5th over x to the 5th? What's the rule? 0? What's the answer? Simplifying this is anything over itself is 1, right? If I have 28 over 28, the answer is 1. Negative 16 over negative 16?
1.
Okay, so x to the 5th over x to the 5th is 1. So, but if I was to subtract this, what would it look like? It would be x to the 0. Very important. Did you know that anything to the 0 power is? No, it's not itself. Anything to the 0. No, well, hold on, I'm sorry. Hold on. Let's talk about this for a second. Stop. We just decided that x to the 5th over x to the 5th. The answer was 1. So if we followed the same rules and we just subtracted here, then 5 minus 5 is 0. X to the 0 is
0.
Stop. We just listen. Are you done? What is this again? We just decided that x to the 5th over x to the 5th is 1. Hold on. It's what?
1.
It's 1. No matter what, it's 1, right? Because anything over itself is 1. So then if we subtracted this, 5 minus 5 is 0, that means that x to the 0 is 1. You just said it, 1, right? It's 1. So then, if anything is to the 0 power, the answer is 1. Because it means if I have mx to the 8th over mx to the 8th, anything over itself is 1. But if I was to actually do this, it would be m to the 0, x to the 0. Right? Which anything to the 0 power is 1. Right? So just remember that. Anytime you see something to the 0 power, it's 1. Okay. Now, here's the deal. All right. What if I have this? M to the 6th over m to the 8th. Now, here's the deal. Suddenly I now have... Well, you can tell me, what is the answer to this? What is the answer to this? We've done this before. We've already done this. What is this?
Oh.
Do I need to write it out? Hold on, stop. Do I need to write this out?
No.
So how many m's are on the top?
6.
How many m's are on the bottom? 8. So this leaves me with 2. What does it leave me with? 2 m's on the bottom, right? So this leaves me with 1 over m squared, right? Agreed? Okay. You've done that. You should know how to do this. There's another way of writing this. Another way of writing this is to actually obey the rule, and that is to subtract these two. What is 6 minus 8? Those two are identical. You need to look at that and be aware of that. Those two are identical. Something with a negative exponent simply means it's 1 over that number without the exponent. So if I gave you this, if I said x to the negative third, that is the same thing as 1 over x to the third. Those two are identical. We just decided that, right? Didn't we just decide that? Look, let's try it again. M to the 9th over m to the 5th, over the 19th. What's that going to leave me with?
M over 10.
What? What is that going to leave me with?
M 110.
M and 110? Tell me exactly what you're going to write down. Write this down. Stop. Here's a quiz. Write it down. Write your answer to this down right now. Don't just talk. It's so funny. You guys always do much better when I say write it down. Otherwise, you guys just blurt out ridiculousness. What is this answer? Gigi, what do you get? 1 over m to the 10th, right? 1 over m to the 10th. How many of you got that? 1 over m to the 10th. Did you get that? Did you get that, Jade?
Yep.
Okay, excellent. Listen, there's 2 ways of doing this, right? That is doing that where you just kind of like envisioned crossing them out. The other way is to actually subtract. What is 9 minus 19? Negative 10. So then another way of writing this is m to the negative 10th. Does that make sense? So then these two are equal to each other. M to the negative 10th is the same as 1 over m to the 10th. Make sense? I hope so. Here's your quiz. Not your quiz. Here's your homework.